Alright, so here's another type of problem. It says determine whether the points in each table lie on a straight line. So for them to lie on a straight line, what does that mean? That means that they have the same slope, right? So remember, a linear function is where you have the same slope everywhere that along the line, right? So if you pick any 2 points, the slope should be the same. The rise over run should be the same from those 2 points to any other 2 points, right? Even if you pick like points that are further away, the slope should reduce to the same value, right? It should be equivalent. So okay, so that's what we know about straight lines, is they have the same slope at from any point to any other point. So here we have a table, so we can find the slope between any 2 points on a table, right? Remember, this represents 1 point, right? 4, 10, that's 1 point. 7, 19 is another point. So if we can find the slope from 1 point to the next, it should be the same, right? So that's what we'll do. So so for the first one, we'll call this y1 and y2, and we'll call this x1 and x2. Okay, so let me erase those because we'll change it up for the next one. All right, so y2 minus y1, so it'll be 19 minus 10 over x2 minus x1. So it becomes 9 over 5, right? So that's the slope. So if the slope is 9 over 5 for these other 2 values, then that means it's a straight line. Let's try it out. So this next one, now we'll use this as y2, and this is x2, and then these will be the ones, right? Okay, for our formula. All right, so 31 minus 19 over 11 minus 7. So 31 minus 19 is 12. 11 minus 7 is 4. 12 over 4 reduces to 3, which is not the same as 9/5, right? So 9/5 does not equal 3. Therefore, the answer is no. These points do not lie in a straight line, right? Okay. All right. So let's try another one. So same thing, right? Similar. So we want to find the 3 slopes from between those 4 points, and see if they lie in a straight line, or see if the slopes are the same, and then if they lie in a straight line. So in this case, y2 minus y1, so 2 minus negative 12, 0 minus negative 3. So we end up with a couple negative negatives. So 2 plus 12 is 14, 0 plus 3 is 3, so 14 thirds. All right, let's see if the next one is the same. So here we have 10 minus 2, 2 minus 0, so we get 8 halves, which is 4. So once again, those are not the same slopes. So since these aren't the same, right, they're not equal to each other, that means that the answer is no. Okay, all right. So in the last couple, since we found that the slopes weren't the same, we didn't have to check the third point, right? We already know that they don't lie in a straight line. But if you need to, or if the first 2 checked out, then you do need to check the final slope and see, does it come out equivalent to the other, right? And here, like 13 over 2, like that one doesn't work either. But even if that one was the same as one of the other ones, they would all 3 have to be the same, right? So So it's a little less work if you have to check if the first two don't check out, because then you can stop there. But if they did check out, then you'd have to check the third slope. Okay. All right.